One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. So today we are going to be looking at the debugger tool as promised from the last video. So what are we going to be looking at? We're going to be seeing this transversal through the BST tree and how it returns a sorted list, and basically how it works within the code, right? So that's why we are using our debugger tool to also explain this and to also give us a better understanding of what we are talking about. So let's get into it. So now we've called the debugger tool and we've stepped into the function from here, and now we are in the function. So we declare our root and point it to current. Stack is established as an it should be empty right now. Okay, that's let's play, skip through. Yeah, you can see the stack instantiated, and then okay, we begin the while loop. Now stack is empty, current is pointing to 4, right? You see here pointing to 3, but the value of this 3 is 4 because we know we are the root, right? So yeah, you see it here value 4. So we continue, we are at 4. So let's begin to transverse. So we are at 4 right now, and we append 4. We move to the left, right? So we've added 4, move to the left. Okay, let's see if we have anything change. So we don't have anything change over here, but current should be able to tell us that this is now 2, no longer 4. So we continue, we go to the left. We should be able to see 1. So we go to the left. Yep, we move to the left right now. Let's see. So this is none, right? So yeah, everybody is 0 right now in this stuff. So yeah, okay. This is sorry. Sorry. Yeah. This 4, this 2, this 1, right? So interessant. So now we are done. We should be done now with this. So current is none, so we can't move any further. So we jump through the current list, and then we say current equals to stack dot pop, right? So we go down into the stack. We have our 1 at the head of our this thing. So at the basically the last thing that came in, so we pop it. So let's see that works. So we see now that our stack is basically 4 and 2. 1 just left the chart, right? And then that's what is printed out here. I think we should be able to see that. I don't know. Okay, it doesn't show us the value of what was up, but yeah, let me see if we have a special. Okay, that's like 2. It's giving us the stack information. Okay, yeah, this is the current. So yeah, this is the value that we just popped out, and it is 1. So we print out that value, right? So 1 has been printed out. So we go to the right. Now, yeah, let's step into that. So I think current now should be able to define that as 1. Okay, let's see. So yeah, so now current is none because we've gone to the right of 1, right? So is current. So, yep. Yeah, current is none, right? Because we have that, but our stack now has a value. So we continue our while loop. So we go down. Now we have current as none, so we skip that while loop. Now current is still none, so we do current to be pointing to the stack dot pop. Now we have our stack over here, 4 and 2, so 2 should follow suit. Now we continue, 2 left the chart. Now we go to the right of 2. We go to the right of 2. Let me see whether we get that updated before. No, we don't. So but we get it now. Where we check our current and we have it to the 3 because we've moved to the right. Now our next course of action will be going to this while loop to then append 3. So let's append 3. So you can see that here. Where's the start? We still have a 1. Look at the thing. Where's the start? This is here. This 3. Added right here. So we have our 4 still at the index of 0. So the index of 1 has 3. So we now have none. So this while loop is done, right? And we continue that road, right? So we start the pop. This should be 3 at this point because yeah, we are popping 3. So we continue, we say print variable, boom, boom, boom. We go to the right. Right is none, as we have earlier seen. Right will give us none because of the three we are working with. So yeah, just to give some graphical illustration, we are three, we've gone to the right of three, we have none. Now, what else? We also go continuously to the right, and then we um with three we have zero. So obviously there's nothing to append to the stack. So we jump the while loop here. So current is still none. So we go ahead to pop out or print out 4. So you can see that here. So you see 4 is printed out, and we even have, yeah, that's the root. Let's just look that up. We can have the current open. So now we see the current is 4 and our stack is empty rather. So we print out current should be updated in a jiffy. We've gone to the right, which is 6. So we continue that iterative call. We just continue on it up until we get the entire list printed out as we see here. So that's it for the debugger tool. So we just continue. Just let me see if I can play through. We have 5. We print out 5. I think this is when it goes to none. So let's continue the same process. This is the right of 5, and we're done with this. We go back to 6. Yeah, so basically that's it. Now we are 7. Current keeps changing and we keep printing it out. So that you see how the algorithm works. And yeah, that's basically it for the debugger tool. Not to take much of our time anymore, let's just go to the next one where we'll be talking about complexity. What now the complexity when we use a stack, and then hold that in mind as we then go to the optimization. But before the final optimization, we are going to be looking at something called the Morrison Traversal. But yeah, that's to come. Next up is complexity of this implementation, and we see how everything works. So yeah, see you on the next one. Muchas gracias. Bye.